Hi guys, let's move on to part 3 of blood flow, second section. This is a section where we talk about disease more and atherosclerosis. If you break down that word atheros, it means porridge, sounds terrible, and sclerosis is abnormal hardening. So look at this vessel here. It should have a lumen that is completely open like this. And change the pen color here. If you went to blue, you'd be able to see that it should be, open like this. And instead, you have all this deposit here of this plaque. If you look at it in a real photograph, you see that this whole section here is plaque. It's deposited under that endothelium. So that's atherosclerosis. You have fat, you have calcium deposits, and all that together is called plaque. And it accumulates in the artery wall, kind of beneath the endothelium. So this would be the endothelium here in brown, and deep to that would be this accumulation. The actual word arteriosclerosis is the hardening of the artery, and atherosclerosis is the deposit of that fat. So those two, the hardening and the deposit, is going to create greater peripheral resistance, right? That's what we've been talking about. So let's look at it in stages. If you looked at the stages of plaque formation, let's start out with an arterial wall that looks pretty normal. So what you would have are these endothelial cells that line the inside. Remember, this would be the lumen here. That would be the inside. And you have the lining that looks nice and tidy. Then you had some elastic connective tissue that would separate that endothelium from the smooth muscle cells. And there you would have those all in layers of smooth muscle cell. And that's what it would look like in a normal arterial wall in a young child, maybe. And you could then progress towards something called a fatty streak. In a fatty streak, look at this yellow accumulating here. So that is low density lipoprotein, cholesterol, accumulating between the endothelium. Okay, so I'm not going to pile it on here. I'm pulling it under the endothelium and the connective tissue, and it's oxidized. So it's sitting in here, and what happens is that it shouldn't be there. So these macrophages, cells that are migrating towards area of damage and trying to remove that damage, migrate to this yellow area, to the cholesterol, and start eating up that cholesterol, and they bloat up and they look like a little foam cell. So the term there is foam cells for those macrophages that have ingested some of that cholesterol. Notice that the muscle that was nice and tidy in a row down here now is attracted by that macrophage, by the cytokines released by the macrophage, and they divide and they start to take up cholesterol. So this whole structure has been disrupted. If we progress to the next stage, where you would have a stable fibrous plaque, you have lots of the cholesterol still accumulating. You still have those foam cells. You still have muscle cells that are out of place. And maybe you also have calcification. So this here is all calcium deposits. And that sounds pretty nasty because you can feel that very hard inside the arteries. But in a way, it's almost good because it makes this whole lesion more stable and less likely to erupt and, form a clot. So this is going to allow it to become more stable. So this is what this is looking like. The smooth muscle cells divide and they make this lining thicker. A vulnerable plaque then is not a stable one, is one that could potentially rupture. And then you have the leaking out of some of that cholesterol into the blood, and this could easily form clots because you have platelets that are exposed to collagen. They could easily initiate a blood clot after that lesion happens. And then you have a blood clot moving around that could reach the brain or could reach the heart and cause either a heart attack or a stroke. So to be more precise about plaque, it's both fat and cholesterol and calcium and cellular waste, all this junk, fibrin accumulating there in the arteries. It begins to accumulate as early as childhood or teenage years. So depending on your genetics and your diet, along with those two, you could begin to have plaque as early as in your second decade, from 10 years on, actually. Fatty plaque is about 25% less stable than calcified. That's what I was telling you, that if you have more calcium deposits, it's less likely to erupt. Statins are going to reduce the fat content of plaques, making them more stable also. Inflammation or infection also weakens the plaque. We don't really understand this, when it is that these get weakened and why you would have a rupturing of that wall, but we think that inflammation can cause this. This is a diagram I think that's very helpful. It has the progression, how you could have a lining that looks quite normal to the fatty streak, to a lesion, to an atheroma, fibroatheroma, and then a complicated lesions. Just slightly different vocabulary here, but it's the same thing. It's the progression over to this extreme fat accumulation and potentially the rupturing of it. On this side of the graph, you have age, like earliest onset, first decade, earliest onset here, third decade, and so on and so forth. So this progression could not happen at all, or it could happen, as I said, depending on both genetics and diet. We have some pathology vocabulary that I wanted to show you. I'm just calling it path vocabulary in cardiovascular. And so I wanted to just list it for you. Ischemia is the inadequate oxygenation. So this can be caused by blocked arteries, atherosclerosis, anything that's going to cause the inadequate arrival of oxygen is ischemia. Angina, or angina, it's pronounced both ways, is referred pain. So the pain in the arm, pain in the back, resulting from a heart attack. Myocardial infarction is cell death. So myocardial infarction is showing that there's been cells that are dying within the heart. Hypertension, we're going to classify that as systolic pressure above about 140 and diastolic above 90. These parameters change over time. I'll show you another chart referring to that. Look at this. So normal, below 120, we're saying now, and around below 80. Elevated, anywhere to 120, 129, and still below 80 would be elevated. High blood pressure in the 130s. Stage 2 high blood pressure would be 140, and then hypertensive crisis, which is above 180. This is not something I need you to be memorizing. I just want you to get an idea of how these numbers, how we evaluate that blood pressure. And this has been changing. Before 120 and 80 was perfectly normal, and now we're saying that below that would be better. I'm going to stop that right here and have a fourth mini lecture for this series. Okay, thanks for joining.